Hi folks, this is number 3 from the Unit 2 assignment extra questions. Okay, so here we've got a couple of crazy chain rule questions, but what I really want to put across here is that while these look very ugly, if you take them in small steps, they're actually not that bad. Okay, so first thing I'm going to do here is I'm going to rewrite this function so that it's in a more user-friendly form for using the chain rule. So while this tan cubed is really nice for writing it out, it's maybe not quite so easy to see how the chain rule is going to apply. Okay, so the first thing I'm going to do is rewrite this. Okay, so I'm going to take this tangent that's being cubed, okay, and I'm going to write it in this form. Okay, so now let's look at the input of the tangent. I see a cube root. So again, I'm going to rewrite this as, okay, log base 3 e to the x, and this whole thing is going to be to the 1/3. So all of this is the input to the tangent function. Okay, and so now it's a little easier to see how the chain rule is going to work. Okay, so I'm going to give myself lots of room. Remember that when we're applying the chain rule, the only thing I care about is one function at a time, and we're going to go from the outside to the inside. So if I look at the most exterior function here, it's just this whole thing u cubed. Okay, and how do I find the derivative of u cubed? Well, it's just 3u squared. So it's just 3 times this whole expression, tan of, okay, you know, here I'll write it as a cube root to make it easier to write, or actually no, I'll stick with the log base 3 e to the x, okay, all to the 1/3. There you go, and this is going to be squared, so 3u squared. Okay, and now I multiply that by the derivative of the inside function. So the inside function is going to be the derivative of this here. But this is again another composite function. So the only thing I care about is the outermost function, which is the tangent. And what's the derivative of tangent? It's secant squared. Okay, so it's going to be times secant squared of this whole input, log base 3 of e to the x to the 1/3. Okay, there we go. So now I've taken care of the tangent, and now I'm going to go inside. So now it becomes the function I'm taking the derivative of. But again, think of this as, you know, v to the 1/3. Okay, so how do I find the derivative of v to the 1/3? Well, it's just 1/3 v to the negative 2/3. So times 1/3 times this whole thing, log base 3 of e to the x to the negative 2/3. Okay, and now I move inwards again. So now I'm going to take the derivative of this function here. Okay, but this is again a composite function. This is like my w. What's the derivative of log base 3 of w? Well, it's 1 over w ln 3. So 1 over w e to the x ln 3. Okay, and then finally I move to my innermost function, and what's the derivative of e to the x? Well, just e to the x. Okay, so when you look at this original function, how many functions are being composed here? Well, there's the cubed, there's the tan, there's the 1/3, there's the log, and there's the e to the x. So it's a composition of 5 functions, which is why I needed 1, 2, 3, 4, 5 terms. Okay, so the idea here is to think of it as one function at a time from the outermost to the innermost. Okay, so let's do the same thing in the next question here. So if I take a look, how many functions do I have? Well, I've got the e to the x. I have this expression squared, so that's 2. I have the sine, that's 3. I have the ln, that's 4. I have the x squared, that's 5. Okay, so yet again I should have 5 terms here. But I've got this issue with the sine squared. So I'm going to start by rewriting this as e to the sine of ln x squared, okay, all squared. Okay, so let's start now. What's our outermost function? Our outermost function is e to the x. Okay, and what's the derivative of e to the x? Well, just e to the x. So I still have e to the sine ln x squared. Okay, hopefully I don't have too many brackets there. Times, now let's go to the inside, which is going to be the variable in this exponent. So this acts like u squared. What is the derivative of u squared? Well, just 2u. So my next function is 2 times this whole thing, times sine of ln x squared. Okay, so let's move on. Now I go to the interior function again. I have a sine function. What's the derivative of sine? Just cosine. So it's going to be cosine of ln x squared. Okay, let's move now inside again. I have ln of x squared. Okay, so that now acts like my u. What's the derivative of ln u? It's just 1 over u. So it's times 1 over x squared. Okay, and then finally I get to my innermost function. So what's the derivative of x squared? 2x. Okay, and again notice that I have 1, 2, 3, 4, 5 functions. The outermost function, e to the x. The next function, x squared. The next one, sine x. The next one, ln x. And the last one, x squared. And it's just, that's why we call it the chain rule. It's like a chain that links together the derivatives of the outermost function all the way to the innermost function. Okay, that's it for these.